second part of the sessions on visualization of car sharing, bike, and transit data. So if you were here for the first one, I talked about car sharing. Now we're going to switch it up. We got two groups that are presenting, and they're going to be talking exclusively about transit and transit visualization. First off, we have Nikki Foletta and Chris Pangilinan from the Fair and Pierce San Francisco office and the San Francisco MTA, respectively. So, you guys want to come up?
Thank you, Jorge. Hi, everyone. I'm Chris Pangilinan from the San Francisco MTA. To avoid confusion with New York's MTA, I'll call ourselves Muni. And also presenting with me is Nikki Foletta from Fair and Pierce. And we're going to be talking today about a great tool that we helped develop called Reliability Plus, which is how we visualize our transit reliability data at MTA. Is one way of doing it. So an outline of the presentation that we'll give here is, first I want to talk about the data sources that we have at Muni to talk about our transit bus location and passenger data, and sort of the need for strategic planning, which overarches all data collection and reporting. Finally, we'll go through the tool itself and applications, and then discuss some final thoughts about the tool. So first, we have two sources of main data over at Muni. One is our automatic vehicle location data, which collects location data for 100% of our bus fleet, and rail fleet as well, and gives updates every 90 seconds of the location of our vehicles. We also have automatic passenger counter data, which collects data on a third of our bus fleet, but not on our rail, and this collects in and out data for passengers 24 hours a day. And that way we can get a count of our busiest stops and where people are getting on and off the buses throughout the city. What we're working with is our general transit speed specification. This is sort of a standard that we're working towards using, for our schedule data, as well as looking to use for our AVL and APC data as well, so we can help comply with standards that are slowly being adopted around the country and the world to make transit data analysis easier for those that wish to embark on that. There we go. So one of the big overarching themes that is needed for effective use of data is strategic planning. And at MTA, we've established our strategic plan for the next 5 years. And what this does is it calls out some performance metrics and goals for us to meet as an agency over the next 5 years. And one of the goals I want to highlight, which is relevant for the tool, is looking at our bunches and gaps. So anytime we have buses bunching within X number of minutes with each, or 2 minutes spacing between buses, or more than 5 minutes ahead of its scheduled headway is a gap. So anytime that happens, it's poor customer service. People see it as a waste of resources when they're bunched, and they perceive it as a long waiting time when there's a large gap between buses. And so we want to eliminate as many bunches of gaps as possible over the next 5 years. Now what this does for data analysis, it sets up a goal. It sets up something that we want to measure, and it sets up something that we want to strive for as we move forward with our operations plan. So I'll turn it over here to Nikki to talk about a tool to help look at how we can evaluate those goals.
Thanks, Chris. I'm Nikki Foletta from Fair and Pierce. So this tool this Reliability Plus tool, really initiated as a collaboration between Muni and Fair and Pierce. We were recognizing that transit agencies have a lot more data available, and we wanted to create a tool that would help us to clean, organize, and visualize that data. We were able to actually utilize internal research funds at Fair and Pierce to develop the tool, and now that we have it, we can apply it on projects. Like a lot of the tools we're developing at Fair and Pierce, one of the main goals was to better utilize data to make decisions. The data set we're using in this case is AVL data, which is more or less bus GPS data, which comes in these big, kind of hard to manage data sets. What our tool does is it cleans, organizes, pulls out metrics from the data, and then visualizes them in a way that helps to inform policy and investment decisions. So now I'll get into a little bit of a description of the tool, the Reliability Plus tool. So the tool takes as inputs route, stop, and segment shapefiles. The user has the flexibility to actually define the segments of the route that they want to analyze. And the tool also takes as an input a raw AVL text file as an input. The tool operates on an ArcGIS platform and uses Python scripts to clean the data, organize it, aggregate it, and calculate performance metrics. The main performance metrics that the tool currently calculates are travel time, speed, and reliability. The way we're calculating reliability is a little bit different from the typical on-time performance metric that a lot of agencies use. We calculate reliability as a coefficient of variation of travel time. That's the standard deviation of travel time divided by the average travel time. So what that tells you is if a segment has a low coefficient of variation of travel time, the transit vehicle always takes about the same amount of time to travel that segment. So the coefficient of variation is low, but the reliability is high. If the coefficient is high, that means that the time it takes to travel that segment can vary a lot, so the reliability is low. Especially in systems that have low headways, so buses come pretty often, this type of reliability is more important to passengers than the on-time performance. Passengers might be more concerned with whether their travel time of their trip is reliable than whether the bus is going to come on time. So now, get into the visuals, the fun part. So we actually applied the tool using a month's worth of data on the 5 Fulton route in San Francisco. And here is one of our sample visuals. So we're showing 2 metrics here, speed and reliability. And we're showing it both by location and by time of day. So the red coloring here represents slower speeds, whereas green are faster speeds. Red means less reliable, whereas green means more reliable. So some things you can pull out from this visual, you can see that in the downtown area, speeds are slower, which is expected. There tends to be higher congestion in that area. Once you get out to the avenues, speeds tend to be faster. One thing that jumps out that you're able to see from looking at the visual is that around 10th Avenue, speeds are actually quite a bit slower than the surrounding area streets. If you compare it to the reliability metric, you see that actually 10th Avenue is fairly reliable, so that segment is actually reliably slow. So similarly, you can see the avenues tend to be slow, but not as reliable. Around McAllister tends to be slow and a bit more reliable, and then downtown tends to be slow and the least reliable area, especially around 5th Street. So really, you can quickly just gain a lot of information from a simple graphic like this. This actually presents the same data, but on a map, in a map format. So it tells a bit similar information. So a few differences are that the other graphic only showed one direction, the westbound direction, whereas here you can see both the westbound direction and the eastbound direction. The other graphic you were able to see multiple times a day at the same time, whereas this one you are only looking at one time period. And so on this top graph you can see downtown is slow and 10th Avenue. Another insight you can gain from this graphic is that the unreliability tends to be higher on the westbound direction than on the outbound direction rather than the inbound direction. Another way to visualize the data is through Whisker Plots. So here we have speed and location. The box shows the 25th percentile to the 75th percentile of speed. The whiskers show the 10th to the 90th percentile, and the color is, each color represents a different time of day. So we can see tighter boxes represent a more reliable system, whereas the longer boxes represent something that's a bit less reliable. So another way to just quickly visualize metrics across the system. So we've also put this into video form. Same data, just a different format, different way to initiate some discussion. So this shows a video of how the speed changes throughout the day. And that one difference is that the height, you can actually see the height of the bar. The height represents the speed. So a higher bar is a faster speed, a shorter bar is a slower speed, and the colors also correspond. So you can actually see the order of magnitude differences between speeds on different segments across the route. And the graphic also shows the slowest and the fastest segment for each time of day. So this, you can also kind of see around like where 10th Avenue is located, the fact that it's slower than the surrounding areas. And for the 5 Fulton, the speed actually doesn't vary that much throughout the day. It's something we kind of gathered from this. For some routes, you might think around the peak hours, you might see the speeds being a bit slower. Another way that we've been able to visualize this data is through an interactive web map. So we've taken data from an M light rail line in San Francisco, taken the same metrics, and put this online. So now the user has the ability to decide which metrics they want to look at. For example, so this is speed. So the greener parts are actually underground. Oh, this doesn't work very well with. Whereas the red parts are above ground, so you can see the difference how the underground segment actually makes it a bit slower. The web map also allows you to zoom in on different areas. You can change the base map so you can actually see land uses behind. So here we can look at either reliability or speed. So this is the reliability of the segment, and you can also select which time of day you want to look at. So for example, we see in the AM period, there's really a bottleneck where a tunnel exists, where the train is coming out of the tunnel, or no, there's other trains coming from above ground into the tunnel, and that really tends to reduce the reliability of the train at that location. And then the speed is kind of interesting because you can see when it's above ground, it's much faster. When it's below ground, it's slower. It can help you like pinpoint areas of concern and areas for further analysis. We can zoom in on certain areas if we want, and then check out a different base map just to see what's going on in this area. Look at uses and things like that. So, and then this is great for sharing with the public or sharing. People can just log onto the website and play around with it themselves.
So you're saying we should bury the M, right?
Yes, I think we have some others who would agree with that. So those are a few of our many data visualizations, different ways to view the same data and get different insights. So Chris will now talk a little bit more about the applications.
Thanks, Nikki. Yeah, so the tool really gives us a great way to look at our data instead of in a spreadsheet form, in a nice graphical format, of where our trains and buses are either slow or unreliable, which of course are two of the most important metrics for transit riders. And some of the applications that we can use this for include, as you can see in the upper left corner, so we painted some red lanes, so like what New York did in Manhattan on Church Street, to see how this affects our travel speeds on the buses and trains in the area. We can look at before and after. And we can also start prioritizing areas for investment. One of the areas, remember the 10th Avenue on the 5 Fulton we were just talking about, it happens to be an entrance to Golden Gate Park, and there's a traffic signal and a bus stop there. And that area we can start looking into and say, okay, do we really need that bus stop? Do we need to park or change the signal timing there, or what do we need to do? Another application that we can look at is is sharing with the public. And so this is sort of an infographic that we started developing for outreach with the public. And so while the data is great in terms of reliability and minutes saved, it doesn't really translate to something that can really have an impact to the public, where 30 seconds sounds like not much, but of course for transit people that's a lot. So if we can translate that using ridership and sort of a prevailing wage, we can translate that for 12,000 people on the bus, can save 3 minutes, and so on, adds up to a lot of money per year in terms of economic impact. And using graphics such as these, which can be a derivative of the data that you already have, without much work, you can actually have a much more impactful message to the public, to policymakers about why investment is so necessary for a transit agency. And so finally, sort of to summarize what we just talked about here, data visualization basically provides a new way to look at transit data. One that is much more compelling and can tell a good story about why an investment needs to be made or what's going on in the system today, as well as it can inform management and planners and engineers about what some problem areas are and where we need to make some investments. And like the last slide showed, customer outreach and public outreach is an extremely important part of what we do at transit agencies in order to get the political support we need to make projects happen. But above all of this, though, above all what we presented, the data quality has to be there, and that's the first and foremost step, is making sure that the quality data that you're getting from your agency, from your buses and trains, is good data. So thank you very much. We can maybe have a discussion about this, take some questions right now. Thank you. Yep.
We have seen here a demonstration on a specific line, and we consider also to apply this for the overall network and maybe to study the impact of variability in connection between these different lines.
Yeah, we definitely would like to expand the tool to, we'd love to do like a network analysis. We're still kind of researching and building the tool. Like there are already some applications we can apply to projects, especially if we're looking at an individual route. But we'd like to continue to expand the tool to make it more useful looking at more routes. So right now we're kind of adding one route at a time. The process requires us to pull out one route at a time, but we might find ways to make it more efficient, automate that a bit more. Yeah.
I just had a question. In terms of like the value of the tool, as like with US DOT investing a lot in the RETIS application, so to speak, which do a lot of similar things, maybe more for the roadway segment, not maybe as much for the transit. Was there like any correspondence done to see if the existing RETIS tools can be repurposed to do this on the fly?
If the existing what?
Are you familiar with the RETIS environment?
RETIS?
That is run by Michael Pack and others out of UMD College Works.
Does that use AVL data, fast GPS data?
It uses like probe data of all for regular cars, yeah, so that might easily be repurposed to do the transit thing. So one of my questions was, instead of rebuilding from scratch, there's already so much investment made into that tool, why not repurpose that for transit applications?
Well, I'll answer that since I'm
there you
go.
Yes.
We don't actually do that much with transit data right now. It's something we'd like to do in the future, but you know, we're not very transit-centric right at the moment.
But Michael, don't you think you have all the tools to exactly generate all these things once the metrics start coming in?
Well, not exactly. We don't do everything that they showed, but we're working towards that way.
Yeah, I think it's an interesting field, the transit field. I mean, it's very open right now. I think repurposing a tool is something that should certainly be looked at. So we're fortunate that Fair Appears is able to offer some sort of lab time to develop this tool, and MTA, Muni, I should say, was having some time also to make this happen. And I think the more that we can explore this field, the more we can come up with new innovative tools like this.
I think, Chris, that you said that the buses report the location every 90 seconds on the GPS. I'll call that the temporal resolution. That hampers, I think, how fine you can say that either the speed is or where it's actually happening in between. Is there some effort to try to see if there's more, you can get a smaller temporal resolution of the reporting, or is the distances that you're analyzing taking that into account? I guess either one of you.
Yeah, one of the distances. I mean, I was going to say about the density that it's reporting at. I think what's interesting is Next Bus it comes from NextBus, which is originally a customer information tool, and we're sort of repurposing that data for evaluation and management, which is I think really cool, but it definitely wasn't meant for this. And I think with our next iteration of automatic vehicle location and passenger counter tools, the finer grain the better, like you said, so that we can get more block-to-block specifics. But Nikki, you kind of overcame this with some.
Yeah, we definitely looked at that. We defined these segment lengths ourselves by looking at the frequency of the data points we were getting to make sure we were getting enough data points that we felt like we knew the speed on each segment. So yeah, that should definitely be looked at when you're defining your segments, and definitely when there's more frequent data, that's better. We're also looking at incorporating automatic passenger counter data outputs into the tool, and that gives you information at every bus stop. So that would kind of be looking at the data a little bit differently too. You could, instead of having these segments, you could just have segments between bus stops.
For the reliability measure, have you compared the on-time arrival with your variant-based method? How different they are?
We haven't compared it, and the MTA already, or Muni already calculates on-time performance internally through a different process. So we didn't want to necessarily replicate that process with this tool. We wanted to do something different. We could definitely calculate on-time performance, but we're just balancing what's useful to add to the tool, trying to prioritize what this tool can do versus other tools.
Does Muni have time checks in their route system? So like if a bus gets to a stop early, does it wait at a certain spot, and do you factor that into your analysis here?
No, the routes all have time points, which are about half a mile apart or so, or more. And those, our operators are required to be -1 or +5, -1 minute or +5 minutes at those points. Definitely not early, but if they're late, they can't help it at that point.
Yeah.
So they should be, they drag the line or catch red lights in order to try to stay on time if the schedule allows too much time there.
I was just wondering that 10th Avenue segment, if that was a time check issue as opposed to the
Oh, it's
actual.
usually why they're dragging, maybe you mean?
Yeah.
It's a possibility, and I think we're kind of looking at that too, is maybe we have a really strict supervisor who happens to be there and all the drivers know it or something like that.
So you mentioned the automated passenger counts. Have you thought about taking that, so you're talking about reliability here, but maybe taking it one step further and combining it with that passenger count to figure out what the impact is? So if it's very unreliable, but nobody's riding the bus there, does it really matter that much? Whereas, a coefficient that doesn't seem too bad, but you have a lot of passengers in that area might be impacted much
Yeah,
more.
weighting it by the load, the passenger load, yeah. That's actually one of the next steps we're planning to do. Yeah, I think that'd be great addition. Yeah.
Yeah, the visualization website just shows, is that open to public or it requires?
No, right now you need to enter in a password in order to access it. We might start looking into more like, putting it on our website and allowing people to access the web map as an example, but I don't know, maybe Corey has more insight on that.
We're working on that.
We're working
There's some
on that.
IT challenges.
Keep checking out our website,
That's
Fair
right.
Pierce, and maybe we'll have more updates.
So speaking of that, can you give us some background on how the tool came about? Was it Fair and Pierce's idea? Was it Muni's idea?
Yeah, it was actually Chris and I having lunch together,
Alright.
discussing just the ways we could push the industry forward. What did Muni need? And so Fair and Pierce actually has this great program called Fair and Pierce Labs, where each of our offices has a research fund pool, and if we can think of a good idea to invest, to create a tool or create something that maybe can help our industry, we can invest some time and resources into it. So we decided to invest that money, our San Francisco office decided to invest that money into this tool. Muni helped give us data and an idea and guidance on what would be useful for them. So it was kind of a collaborative effort, and now we're using the tool on projects, so we're getting some return on the investment.
And I'll just add to that too. I think this was a kind of an interesting case of how this tool even came about. I mean, there was no contract or anything like that. It was just more of again, just us having lunch and saying, hey, we have an idea, we should try to do something. And it ended up being a great, over the last year or so now, working on this, make it happen. The other thing that we've been doing too is at MT we have our own internal Transtat, we call it, based off of Tableau. It does similar kind of analysis, and it's a little bit inspired too by this work too. So what's great is that now we have our own internal tool to help analyze routes at APC, and we can sort of look to this to help keep pushing the envelope to see what we can adopt internally as well.
So I'm a little curious, it looked like you're using an S3-based tool. What kind of licenses did you have to acquire for supporting it?
Maybe Corey knows more about this.
Maybe a little bit more, but the mapping and the analysis has been really important to us to be able to bring that to bear on all of our consulting. ArcGIS for server was what we got. The licensing I'm not completely clear about. We have a handful of GISPs, professional GIS people who handle our installation. So if anybody wants the answer to that, I'll be happy to get it for you, but I'll have to get it from one of them.
And the tool is created using ArcGIS and a lot of Python scripting.
And I guess one more thing, the data that goes into the GIS tool is all available also on, I believe it's sfdata.gov or datasf.gov, one of the two. But it's all open data, so the whole public has access to this data as well.
Yeah, I think so. Maybe we'll pass it over to Ellyn now. Go ahead.
I want to bring yours back to New York. I have to do a little technological change here first. Okay. I am here, I'm with an organization called the Permanent Citizens Advisory Committee to the MTA in New York. And we were created by the New York State Legislature to represent the riders and advise the MTA on problem areas. And so we come at this a little bit more from the external stakeholders' point of view on wanting access to data for various reasons, for whether it's an article to be written, a piece of testimony, elected officials as stakeholders. So that was where we are coming from in terms of wanting greater data visualization to understand the authority. So what we really wanted to help the external stakeholders understand first off was where the MTA was doing well and where it needs to improve. It's gone through a lot of years of being slammed, and there was a lot of frustration in that there's been tremendous good work having been done in the last 30 years actually since it started as a capital program that nobody was talking about. And so understanding those differences, and then from that understanding, having a better idea, knowing where it needed to invest. So the MTA has, I think I first heard the term here, data-rich, information-poor, DRIP. It puts out 1,000 pages every month of performance data and other information. It's very intensive to try and read and then translate. And so we wanted to address that problem. Here's one of the static pages in one of those 1,000 pages where you can see this is just some of the performance indicators for New York City Transit. And you could see where every month your eyes would start to cross in trying to get through this. And because it's static, it also didn't have, it just has last year's metric compared to the current year. It didn't give you the perspective that we were looking for, like the stock interactive sites have, where you could see, okay, 3 years ago what was happening, 5 years ago, and then when you look at 10 years, you realize, oh, we thought we were doing well, but look, we still haven't caught up to where we were 10 years back. And so we wanted to bring data visualization to the MTA and in a more proactive way in many more departments to accomplish this. So yes, we thought, great. The solution was data visualization. And we begin our meetings, we had great access to whatever departments we needed to meet with, and we started the meetings. And the first term that really paralyzed the discussions early on was data visualization. And the anger in the room that would occur as we were doing this, and probably 6 meetings in, we thought we better take a step back and re-examine how we were going about it, because we were not making any progress on our belief in how important this would be to stakeholders. So it was unsuccessful. We decided what we needed to do was develop a demonstration project so that to engage the different departments. And we wanted, with the goal of reducing the 1,000 pages into more efficient interactive reports, and to use the trend lines so people could see much more where we've been and where we were going. The difficulty in whether it's testimony or reports that are written, all these little bits of statistics and performance measures are thrown in, and every time I read them, I need that in perspective. What is that? And they're just little nuggets that you saw over time, and so we wanted to address that. So we took 5 years of transit performance data, and we identified a program, which I'm going to show you, called ROMBI. And we took that data, it takes it out of Excel and much more advanced data programs, but, and this is the setup that we used.
Can I ask you a quick question?
Sure.
When you say you took 5 years of transit, you didn't go through 5 years of those paper documents and type.
Oh, no. No, thanks. No, the MTA has been very proactive, probably in the last 5 years, and had a developer's website that it's put together for, well, now that's for 3 years, I guess they've had that, for app developers to work with. And so this performance data had been just sitting there and hadn't been worked with at all. A lot of the information there is more real-time data and rider use type of information. But so we decided to take the performance data, and this program ROMBI that I will show you now. So what it gives you are, these are all the performance indicators that they offer, and it's got customer accident rates, employee lost time and restricted duty, wheelchair use on buses, elevator and escalator availability. It's got the completed trips for the bus depots, the mean distance between failures for the buses and the subways, and it has on-time performance by line, and it also it's interesting what you're talking about on the performance level, because we use, that's it, yes, because New York City Transit uses something called weight assessment for the subways. When the frequency is so great, on-time performance is just the start of the route and the end, and the passengers can really have long gaps, you know, because they'll, a train may go express or something and make up the time along the route and still be on time. weight assessment is based on if you have a 2-minute headway and the train is 25% late beyond that, it gets a negative. So that's the weight assessment metric. And this has ridership. So what it does then is it lets you first see the percentage, and it lets your eye go to red being it was a good month, red being it wasn't a good month, and you immediately can focus in. This was predominantly for the MTA board members. These books that are produced every month are for the board members. But so that they could quickly know, okay, I want to take a look at where the problems were this month. Then the 5 years of data is over here on the right, and you have the ability to scale it a bit and pick any of these weight assessment metrics and see how that metric has performed over 5 years. So for example, we're very interested in the correlation between the capital investments and performance. And at the MTA, those have been two isolated silos pretty much. And here, the CBTC was controlled now. What is it? Computer-based train control. It was installed on the Ellyn a few years ago. And where they were able to increase the capacity, I think, by 20 or 25% on this one subway line. And here you can start to see the improvements that happened when it went into use, when they started using it. And we like that this, up top, you can see that in May 2011, the weight assessment was 79.6%, and then it improved to 80.6%. And it goes on like that. So that it puts the access at your fingertips when you're wanting to make the case for capital investment in what you've done before, or you want to look at problem areas and make that case too. So when we brought this into the meetings, it was a game changer from very negative reaction to excitement and wanting to talk more about data visualization at the MTA and people pulling us aside to find out what it was about. Now, we, in taking it a step further, started realizing the value of interactive reports is everything in making the information more intuitive. You can go where your mind wants, just like with that chart. You might start with my line. You know, I travel this line every day, I want to find out more information. Then you may travel someplace and you had an awful experience on that line. It lets your mind go where it wants. And so we thought and started talking to them more about interactive annual reports, whether it's the 5-year capital program, the financial reports. And so this program we worked with, Romby, again, makes their annual reports interactive. So you can go into pie-type charts and go into a depth, and you can also, there's some map interactivity. But we were able to use this to start demonstrating what we're looking for to understand the information that the MTA has and understand why it's important to invest in it. And then the last portion of this, what's possible with reports, is South Africa decided that they would like to, oh darn it. They've started releasing all their data in separate reports, and so they put it in so that now there's bookshelves where you can pull off your capital report, you can pull off your financial report, and they're all interactive. And so that's the sort of the final dream that we have, and the MTA is actually on its way to making that become a reality. So we were successful. Then, come on. The recommendations we made to the MTA was to develop a strategic vision for data analytics and visualization at the MTA, and to create 3 data visualization pilot projects to move data visualization forward among the operating agencies. And today, New York City Transit, the effort is now MTA-wide. The president of New York City Transit is now head of the whole MTA structure and is bringing it to that, which we're very excited about, and he's been very supportive through all of it. The prototypes for the tables are under development. A team of 10 staff and interns created have been added to the project. Academic institutions have been brought on board. There's an increase in financial resources devoted to the effort. Prototypes for interactive capital programs have been developed. And so that's essentially what we've been pushing for. And we hope there's people in this room that will also move towards more interactive reports. When we looked at them, it was surprising to see that even Google and Apple and MIT and Stanford, when you look at their annual reports, they're all static information that don't give you the depth that you might be able to get to really understand what's been happening with them this year, 5 years ago, 10 years ago, to watch the growth. Thank you. Do you have any questions?
Now, NTA is more than transit, it's bridges, tunnels. This information will be performance about bridges and
well, our focus is predominantly on the operating agencies, which is New York City Transit, Long Island Railroad, and Metro North. And so that's where we're spending our energy. I mean, New York City Transit has 43,000 employees, and the railroads are much smaller. But that's where it's starting.
So the concept of the organization is really interesting. I guess one question I have is, when you said that data visualization was sort of that bottleneck out of the gate, what was driving it from MTA's perspective? Was it just a misunderstanding? Was it they were reticent, they were hesitant to do it? They didn't want to deal with you guys, or sort of what was the...
Yeah, no, it was from early on. The president of New York City Transit was interested when he heard about this project, and we started it out of the performance metrics TRB meeting here. We saw the roadside is doing so much. We saw Michael's presentation and thinking, we have to bring this over to transit. So we got back to New York, and data visualization just wasn't on Transit's radar screen, but they were developing a very impressive asset management program. And so at the top level, they were interested in moving in that direction, but this was a little nook of it that hadn't been included. The resistance was, in some cases, it was age-related. It was interesting to have a room where, you know, the new out-of-school kids were like, wow, that's really great, and then the middle was like, that's okay, but I'm not really sure. And then a lot of people are retiring at the MTA. They came in at the start of the capital program 30 years ago. And so there's not, you know, it's like, well, I'm leaving within the next 2 years, and that's, I think it's like 20% of top management. It's a scary number right now. But we're pushing that. But you're walking out the door with all this knowledge, and the way to transfer it that'll be understood is to get it into. So you need to stay on board with us, and they've been coming along.
I guess I have a question about the ROMD, the application. I'm curious about how much effort are being spent for you guys to dump your data, load your data to the app, and how much effort are being spent routinely to keep the data, you know, or information updated.
Well, it's We've been using their cloud, which we put our password into, and they've been there for support. But what we liked about the program is it's very simple. I mean, once you get the structures for the spreadsheet, you upload it to their program. You go into Romy and you log in and you attach your file and it goes in and it creates something, you know, it creates what we put there. They did help us when they looked at the data first, and so, but it was all 2 days, and said, here's how you might want to set this up. There's definitely an art to it because, you know, sometimes we've set it up and thought, oh, this is going to be great, and then we popped it into one of their visuals. Trend is just one. They have, I think, about 10 different views, pie charts and things. So there takes some skill in learning what the setup of your spreadsheet should be.
I know in San Francisco we are having to retool sort of our work culture and what we do now that we have all this data in order to use it more effectively. What do you feel like the sentiment is at MTA now that they have this data available in front of them? Are they able to use it effectively, or what do you think the next steps are?
Well, the next steps are pretty huge, and they aren't able to use it right now. Transit has over 1,000 databases, and I love that your program cleans. The data they're putting out right now is they've cleaned for the most part, but it's a large undertaking because the president of New York City Transit is now chair of the MTA. Everything is becoming centralized, and he is sending out letters, you know, to the full staff on, we need to get on board with this. This is, you know, we're moving in this direction. But because they were very worried that they needed to educate themselves on this, and so they're working with the School of Visual Arts right now on workshops, and it's great because, well, and I'm part of this, while we're presenting to tell the students what we need, it's been set up so we are also the students learning at each workshop, because they want to learn and be knowledgeable from the inside before they go out to contract with people and hire to get products produced.
In what you have shown, the reporting was a trend visualization. It was about looking at the temporal dimension of the figures. Do you have also some reports where you will need to understand the data in a geographical point of view?
Not out of Romby. You mean mapping and interactive?
Yes.
So what we created a data visualization for the next 5-year capital program that is an interactive map, and it's making that capital program very interactive. So it's by asset class, rolling stock, signals, and that sort of thing, and going in and having the map with green of what's already been rehabbed and red what's not, color coded, and then like interlocking, so you have the red round balls and show what needs to be done, projected out to 2030. So we're trying to put in front of them the idea of what we would love to see that would make it much easier for transit advocates, elected officials, etc., to make the case for investing in transit.
One of the presentations this morning, there was discussion of bus services and priority bus services throughout New York City, buses operated by the MTA. To what extent is this data set easy to break down from the rail part of the system to the bus part of the system? And are you trying to look at it independently and separately, perhaps different measures or different, or the investments in one versus the other, or how things are operated, one versus the other?
I think the buses and subway getting a little more broken out. The new real-time information, which I'm sure you spoke to, that data is all coming in pretty new. They just rolled it out in Manhattan like 2 weeks ago. And so the numbers we have are just pretty, large of what comes into the bus depot when a trip is completed, that sort of thing. But I think as the real-time bus information comes out, and there's a new bus control center, which will be fascinating, where all of a sudden dispatchers out in the field will be real data on it. I think that'll lend itself to more of a finer grain that I think you're talking about. Please add anything. But the select bus service has some data, but we haven't gotten into that.
I know that the MTA is making enormous strides in collecting information and getting it out. The size of the system that is so enormous that makes this a very challenging.
Yeah, exactly, and that's part of the working with the schools and everything to get knowledgeable on it, because we'll make a mistake on that size and it's very big. Thank you.